So we can get started with this first method here called bad method, and inside of it, it's not a very big method. What we're doing here is having this while loop while true, executing this statement os.fork. So in order to break down what's happening here, I should explain what while loops are. So a while loop is a conditional statement, and where inside of the loop we can execute a set of statements as long as the condition is true. So for example, if I say I equals 1 while I is less than 5, we can just print I, and at the end of this loop we're going to increment I by 1. So how this loop will work is I is less than 5, I is 1 in this case, so 1 is less than 5. We're gonna that prints out the number and increments 1. So the next iteration is 2, then 3, then 4, and once we get to 5 here, this while loop should break because 5 is not less than 5, so the condition is false. If that makes sense. So the issue with while loops compared to for loops is that while loops will continue indefinitely until the condition is false. So you could run into cases where if we didn't have this increment statement here on line 15, what happens is this code will keep executing because it'll run to the end and I will stay 1, so it'll just keep running here. So if that makes sense, let's go back up here where you see while true. This is a statement that will never be false because true will always be true. Inside of this conditional statement, whatever is happening in here is going to keep happening. So the next part here, what is os.fork? What does this command do? Well, to talk about that, I should talk about the module here. OS is a module that's provided in Python that provides us with methods that we use to interact with the operating system, OS operating system. Fork is one of these methods that we can use, and we use fork in Python if we want to create a child process. Sort of explain what I mean by that. A process is an active program that is under execution. It's pretty much encompasses everything about a program that we execute, whatever it is on our computer. And a child process is a replica of the memory and everything of the original parent program. So fork basically clones the first process and creates a replica process. So if we have this while true here, and this will execute indefinitely because true will never be false, fork will continue to create replicas of your parent process, and essentially running this method here will create replica processes on your computer that will keep going. This process will keep going until your computer runs out of resources. So in most modern operating systems, this code should exit out or error out eventually because your computer runs out of resources to run the code, so it'll just stop execution. But in general, this is generally a method that you will not want to run. So that was a pretty harmless demonstration of how while loops and creating replica processes could pose a problem for your computer. But if you want to attack other people's computers, I guess listen on. If you're an attacker, a hacker, or just generally not a good person, you can do something called a distributed denial of service attack, or DDoS for short, if you're familiar with the term. So what a DDoS attack is a desire to block the resources of a server or stop it from executing properly and being able to function by flooding it with a stream of requests from a IP address and continuously bombarding it with requests until that server is unable to function because it has been overloaded. Yes, this is something that happens quite often. A lot of different servers can be targeted, bank servers, video game servers, and anything of the like with millions of users, or a server that has high traffic can be targeted by a DDoS attack. DDoS attacks work pretty similarly to the example that I showed before with the while loop. Inside that while loop, we're creating a replica process, a replica child process. And similar to that, if you want to make your denial of service attack distributed, that means you're sending multiple requests at once. So creating a replica process or a replica thread in this case is what is required in order to have that happen. So within this example that I've shown, I will like to preface this by saying that if you didn't know, DDoS attacks are illegal and are generally just not very ethical things to do. So this is just an example. I am not going to fully lay out how a DDoS attack will work, but you can tell based off of the variable namings, the general method of execution. So I gotta preface this again. Don't do a DDoS, don't do this at home. Maybe you could try it out on your test server or just do it for fun for yourself, but don't do it to other people. So within this attack method, while this is true, we're initializing a socket, connecting it. Here we're sending the request to the target IP address. And then afterwards we close. And here, this right here is just a denial of service attack. As I mentioned before, because what would make this distributed is if we sent multiple requests at once. But in this attack method, all we're doing here is sending one request at a time with each execution of this while loop. So how do we make this distributed? How do we send multiple requests at once? Because again, the goal of an attacker here is to take down the server, and a server won't be overloaded if you're sending one request at a time. If you go here to this method down below, create threads and start, we're going to create, you can see in this for loop, we're going to create 500 different threads that are each going to run this attack method. What makes this distributed is that we're having 500 different threads of executions where we're sending requests to a server. Will 500 be enough to take down the server? If it's super small, I guess, if the server doesn't have much memory space, or expect a request load of 500 requests at once, it could take it down. If you make a test server and have it of that size, that could work. But if you want to attack, I guess, a popular multiplayer video game, a DDoS attack in the millions maybe what you need. But essentially, this is the danger of while loops and coding. But however, this is a lot more focused. It's not really damaging yourself. You're hurting other people, which I don't recommend. So again, don't try this at home. But this is how a DDoS attack essentially works. So for this next example, we are going back to code that will just break our machine. To sort of explain what's happening in this line here, in this command line, we're going to talk about the DD command. How this command works in Linux or on a Unix machine. DD does, it's a utility that lets you convert or copy files. In a Linux operating system, everything is treated as a file. So your disk, your hard drive, and everything else basically is treated as a file. So you can use this command to copy anything, to copy things over to hard drives in your system, to disk partitions, and everything. So what does this line do exactly? Starting from the first command here, sudo. What sudo does, it temporarily grants a user administrative rights to execute commands. There's some commands that you may try to run on your command line that will be blocked because you're restricted and you don't have the required permissions to run the command. Sudo lets you bypass that. Sudo dd means that we want to copy a file or convert a file. So the last two portions of this line indicate the input and the output files of which you're converting or copying to. So if equals this dev/random is the random device on your drive. And what this line will do is copy the contents, the data of this random device to the output /dev/SDA, which is actually your master boot record, which is essentially what your computer needs to run. Whenever your computer boots up, it reads data from this device. What this line is going to do is copy random data from this random device that has data in random blocks and copy it over to your master boot record, essentially wiping it clean, meaning that your device will be unable to boot successfully. Meaning, and when I say boot successfully, that means that your computer will be unable to start. And the only way to reverse this, not actually reversing it, would be to reinstall your operating system. Hopefully if you had a recovery drive or a backup. There is no way to reverse this, as it's wiping clean your master boot record, so do not run this line of code. Again, I'll say this is something that is potentially very destructive to your computer. And last but not least, we have example 3, which contains a line of code that I consider to be the most destructive line of code that you can write that isn't launching a nuclear missile. So here we have the use of the sudo command, which again, as with example 2, it's giving the user its administrator privileges. And we have rm-rf. So rm here is a command used to remove a file, and rf is the -r flag is used to recursively delete files. It's usually used to delete the folder, and f is to force. This command by default is a dangerous one, so most operating systems will prompt you to see if you're sure that you want to remove everything that's in a folder. So adding the f portion to -r will force it and allow you to do so. This part here is the most dangerous one of all. No preserve root, meaning that if you were to run this code from the root of your file system, it will recursively delete everything in your local system, all the binaries, all your personal configurations, all your user files, and even more than that, everything that your computer needs to function. So if you were to run this again at the root of your file system, you may get this command that prompts you if you're sure, and then adding this flag would allow you to not preserve your root. I'm not going to add the actual root directory here in case somebody copies and pastes this and tries to destroy their computer, but it's very simple if you look this up, which again, I hope you do for informational purposes and you don't actually try to destroy your computer. So in conclusion, I hope this video gets across the fact that programming and computer science is a powerful tool that can be used for both good and evil. And of course, just plain destruction. And I hope you learned a lot from this video, and you also learn about the responsibility of computer programming, and you don't destroy your machine or other people's machines. So this is the conclusion of this video. Thank you all for watching, and peace.